Hello physicists and welcome. In this session we'll be covering graphing part 2. Our learning objectives are: I can evaluate units and the meaning of the y-intercept. I can identify a line of best fit, calculate the slope with units and determine the y-intercept. I can interpret changes in slope. And I can identify direct and inverse relationships between variables. Let's get started. It will return to our data here of study time and test scores. But to understand our variables of study time and test scores, we need to have an agreed upon way of measuring that study time. Here we've said that, hey, hours is going to be the way that we're going to measure our study time. It could be in minutes, in seconds, in days. But we've agreed on that hours will be our way of studying time. Test scores. We've agreed on, or our standard way of measuring is going to be points on the exam. It could be percentage, it could be number of questions correct, but we've agreed on here that points will be our way of measuring that. You can see the confusion that would be created if we didn't use proper units or an agreed upon way of measuring this. If I said, hey, you owe me $5 what? 5 cents, $5, 5 push-ups, perhaps 5 homework assignments. But just saying, hey, you owe me 5 wouldn't end up describing what's happening with the variable, what you owe me. Because our graph represents the relationship between variables, our graph needs to list both the value and the unit of the variable. In this case, study time in hours, test scores in points. And by our position on the graph, we can see the value of each of the two variables. Let's look at the y-intercept. In math, you would say that the y-intercept is where a line crosses the y-axis. In physics, we're going to express that slightly differently. We're going to say it's the value of the dependent variable, test score, when our independent variable, study time, is equal to 0. So I have that noted here. So in physics, the y-intercept is the value of the dependent variable when the independent variable equals 0, and 0 whatever units we're talking about. So on this one, with a study time of 0 hours, our test score is 50 points. Hey, a best fit line is a line that represents the collection of our data. A couple of characteristics. It is a straight line. It goes in the same direction as our data. It minimizes the distance between data points and the line itself. And it does not necessarily pass through our data points. We don't just grab points at the end and connect those, but it's a line that goes in the same direction as our data, is close to the data points as possible for all the data points. When we look at slope, we're looking at the rate one variable, the dependent variable, changes with respect to our independent variable. Probably have a pretty good idea that slope is already the rise of a line over its run. Others may know that as the change in y over the change in x, and still others may recognize this as y2 minus y1 over x2 minus x1. All those are ways of figuring out the slope. Let's figure out the slope for this line here. So to figure out this slope, first thing I'm going to do is pick 2 points on the line. I'm not going to pick data points. I'm going to pick points on the line, and I'll pick convenient locations where it's easy to figure out the value. So perhaps right here, and I may do another one. Where's another good spot? Oh, how about right here? They're crossing lines. It'll be easy to figure out those values. Next, I'll determine as best I can the coordinates of our 2 points. This one looks like it's 0.5, and I move over here, it looks like about 63. For this other one, we know that is 1.5. And our other value just below 90, I'm going to say it's about 89. I've determined my coordinates for my 2 points. I'm going to be measuring 0.5 hours, 63 points. The second one, 1.5 hours and 89 points. Okay, step 3. Let's go and calculate slope. So our calculation for slope, I'm going to use the formula y2 minus y1 divided by x2 minus x1. I'll need to have my units in there as well. So y2 is 89 points minus 63 points divided by 1.5 hours minus 0.5 hours. Do a little work on this. I get a value of 26 points for every 1 hour, or another way of expressing that is 26 points per hour. So I kind of expect that for every hour I study, I would get 26 points higher on my test score. Now, something we notice or know about a straight line is it has the same slope no matter where you go along that line. If I were to pick 2 other points, I'm going to start with our original x1, y1. I'm going to have a new x2, y2 all the way out over here. Call that x2, y2. And notice that the line goes a little bit above this last point. So best I can tell, it's around 102. And I'll do this same calculation for slope. We'll see what we get for that. So with our new values of y2 and x2, I now have 102 points minus our 63 points. That value divided by 2 hours minus 0.5 hours. Remember PEMDAS when you're doing this. So 102 minus 63 is 39 points. 2 hours divided, or minus 0.5 hours, 1.5 hours. 39 divided by 1.5 is 26 points per hour. Same value we got over here. So regardless of where we pick our points on the line, we should get the same slope. Just as a matter of practice, try to make them as far apart as possible. You get a more accurate answer that way. And before I forget, just a little more visual representation of what our rise and run is. So our rise in this case will be this distance. I'll run this way. Rise and run. This is probably looking pretty familiar from math as well. Okay, so what does this slope mean? We found earlier that the slope of this line was 26 points per hour. Meaning that for every hour of study we put in, we would expect our score to go up about 26 points. So if you were a half hour into your study, you have an idea of what your score would be, and you wanted to raise that score. Maybe you were you'd put about a half an hour in, and it looks like, oh, you might get a D on this, and you needed at least a C to stay eligible for sports. You may want to put half to 1 more hour of study in. And let's our data points change where the slope of our best fit line went something like this. It was a steeper slope. If our data showed this, we would see that the slope is steeper, which means we have a greater number of points. It would certainly be greater than 26 points per hour. And maybe we'll do a quick check to see what this is. And I'll pick 2 points on here. I'll pick this point here and maybe this point right here. We'll try to figure out what those values are. Right here, I would say that the value of this is going to be 0 and just about 30. Points over here, it looks like I would call that about 1.1, and 100. Let's go ahead and calculate the slope for that one. Okay, so the slope, my 2 points, 0 and 30 for x1, y1, 1.1 hours and 100 points, x2 and y2. 100 minus 30 points is 70 points. 1.1 minus 0 hours is 1.1 hours. We do the math on that, and I get a slope of about 63 points per hour. A steeper slope tells us that there's a greater relationship, that if I increase my study time, I get more of an improvement in my test score, about 63 points per hour. Let's change this slope. Instead of making it steeper, we'll make it flatter. Okay, so here I have another best fit line. It looks flatter. Let's go and take a look at the slope for this. Okay, so my slope for my 2 data points. This data point I would say is at what, 0.5 and 40. This data point is at 2 and 50 points. Let's calculate that slope. 50 minus 40 points. And we'll divide that by 2 minus 0.5 hours. I get 10 points divided by 1.5 hours, and that works out to about, just about 6.6 points per hour. Hey, in this case, the more I study, it's not going to have as much of an effect. So there is not as strong a relationship, or the study time does not influence the test score as much in this case. I want to introduce 2 terms that we'll be using a lot during the year, and that is a direct relationship and an inverse relationship. A direct relationship tells us that, say, when variable A increases, variable B also increases. Or we could also say that if variable A decreases, variable B also decreases. What would that look like in a graph? If we had that, we end up seeing already here is that as study time increases, test scores increase. So this has a direct relationship. It also means that the slope is greater than 0. The slope of this line is greater than 0. In an inverse relationship, when variable A increases, variable B decreases. Or we could say that when variable A decreases, variable B increases. This is an inverse relationship. How do we see that on a set of in a graph? Well, let's say we have the unfortunate circumstance where if we increase our study time, our test scores actually went down. We had data points that went something like this. Hopefully you don't find that, but it could happen. We see that this slope will end up showing an inverse relationship. An inverse relationship because as we increase the study time, our test score went down. And in this case, the slope is less than 0. Or another way of saying that is the slope is negative. Let's take a look where we might see an inverse relationship. Hey, and I've collected data here for the size of a parachute measured in square feet. That would be, how big this parachute is, okay, compared to our landing speed. Our skydiver is falling down. We want to end up having a decreased landing speed because there's less chance of injury. So as we make our parachute larger and larger, we see that the landing speed decreases. That's represented on this graph here. So I've plotted our data points here onto the graph here for all, 7 pieces of data that we have here. A best fit line, I'll draw as best I can, freehand, a straight line that goes in the same direction as the data. And I see that here I have a negative slope. As the parachute gets larger, the landing speed goes down. So I have an inverse relationship. As you collect data and you plot it, that'll be something to keep in mind. If A goes up, in this case, I'm going to call parachute size A and landing speed my variable B. You can see that as A went up, B went down. Okay, so now, let's do a little check here. Okay, our learning outcomes. Can you now evaluate units and the meaning of the y-intercept? Can you identify a line of best fit, calculate the slope with units, and determine that y-intercept? Can you interpret the changes in slope, and can you identify direct and inverse relationships between variables?